So we will begin with the number system. Okay. So there are various examples of number systems. In the earlier days, we used to use a Roman system as an example. Roman numerals or Roman number system. So that was the earlier popular version of number system, because Roman Empire spread across all Europe into Asia and even some of the parts of Africa. So they had a big influence, and the number system which they were using were popular in the early days, but then it was replaced by the decimal number system. Okay, so we are almost not using, but except maybe in certain places like clocks and maybe representing the class numbers, we still continue to use Roman numerals, but in a very limited way. We don't use them for mathematical calculation because it's really inconvenient to use Roman numerals for addition or subtraction or multiplication. This type of operation, it's really inconvenient, so we don't use them at all. But just for numbering, to use a different kind of numbering system, sometimes we use Roman numerals. So what's the basic difference? Why its popularity has gone, and why it is replaced by a decimal number system? So if you look at that question, so there is something very different about the two number system. So in Roman numeral, as you know that you have the symbols starting from, say, I stands for 1, and then you can repeat this I 3 times to have 1, 2, 3, but then after that, so this is 1, then 2, then 3. You can't use a single symbol more than 3 times. That's one of the rule. And then you have to introduce the next symbol, and this is the next symbol. So we have I and a V. So V is the new symbol. So I is first symbol and V is the next symbol. Then if you put this I before V, then we are basically doing 5 minus 1. V stands for 5. Okay, so if you put it before, it is minus 1, and you can only put 1 before. You cannot put 2 before. And then the rule says that you can have this one 2 times, and then repetition is maximum 3 times. So then we have exhausted all the possibilities based on this rule. When you come to 8, you don't have anything more possible, because the rule restricts the utility of I to a maximum of 3 times successively, and you can only put 1 time before the bigger number, or before the symbol corresponding to the bigger number. So we need to introduce another symbol. So that is basically this x. So 1x is basically corresponding to 9. So this means x minus 1. And then x, where x is 10, so then you can go up to xi, x yi, then x I. Then we need to you can still go on like this. This is also possible, and then this is possible, then this is also possible. We are not violating any rules here. Then this one is possible, then this one is also possible, and we can have this one. Okay, so we can still go on without violating any rule. Then you have xx, then xx1. So this way you can continue. Now this will run into problem after some time. When you reach say xxx, maximum you can use 3 times. So the rule says that the numbers corresponding to 1, 10, etc. can be used 3 times. So here we have exhausted, and then after that you can have say 1 x, yeah. So this is basically 39. Now after that you cannot put 4x, that will violate the rule, so you can't have 4x as possible. So now we have again in a situation where we require a new symbol. What is next? So the only way to go forward is introduce another symbol, new symbol. So first we started with 1. With one symbol we could go up to 3 different numbers, and then we have introduced a new symbol, that is this, and with that symbol we could go up to 8, okay, and then we introduced another symbol x. With that we could go up to here 39, okay. So first up to 3 with one symbol we have gone up to 3, okay. So 3 numbers were possible, and then with introduction of the second symbol we could go up to 8. So that is 1, 2, 3, 4, 5 more could be represented. And when we introduce the third symbol, obviously the number of possibilities have tremendously increased, because from 9 to 39, so that is like 19, then 29, 39. So around 31 symbols we could continue, okay. So 30, so we are at 8, then 8 plus 10, 18, 28, and 38. So that is 31. So 31 symbols we could go up to here. Okay, so after this 31 symbol, we have exhausted all the possibilities which are possible with the 3 different symbols. Now we need to introduce the 4th symbol. So what is the 4th symbol? Probably you must know that it is L, and you can put this X before it, okay. So you cannot put V before it, that is not allowed. So only those that correspond to 1, 10 could be subtracted or could be put before a larger symbol. You cannot put V before a larger symbol. So this is another rule. And then so there is lot of restrictions and a lot of things you need to keep in track, and then you can continue. So if you continue from here, the next one will be just like XL I, and etc. You can go, and then you will come to X okay. So sorry for this sounds here. So this is corresponding to 40, and then 41, and similarly 40 to 43, etc. You can go, and then all you need to do is basically just like you have gone from 1, 2, 3, you can I can't help it. Okay, so you have XL, and then you have 1x. Okay, so you can go up to this. This is basically 49, and after that comes 50. So 50 is just L. So this is the new symbol that we have introduced. So the point is that you need to keep on introducing new symbols after some point of time, and the separation or the number of possibilities that will be possible will be exhausted after some point of time. Of course, we are pushing that requirement little farther ahead, but it is never stopping the requirement for a new symbol. So the symbols are required as you go to larger and larger numbers. So this is the way the Roman numerals are arranged, or the rule of the Roman numeral or Roman number system is made. So this after this you can repeat everything here, like up to, I think maybe you can go up to say 89 without requiring any more numbers. So 89 means from 50 to 89. So that's like how much? So that's like around 40 possibilities are there from here onwards. Okay, so then again you will get exhausted when you reach 90. You would require a new symbol. You can't have the 90 represented by using just only this 4 symbols. It is not possible. So you have to go to, any doubts? Okay, so 90 is basically, in order to represent 90, you need to introduce a new symbol, and the symbol is basically this XC. Okay, so that means C is corresponding to 100, and from which 10 is subtracted. So the basic idea I want to convey is that the requirement of the number of symbols never stops. You need to have more and more symbols as you go. Now, prior to the introduction of Roman number system, I mean, you must have seen tallies. Even in the old caves, you have a tally number system, which basically use single symbol, and they will just represent 1 like this, 2 like this, 3 like this, 4 like this, and when you comes to 5, you do like this, and then you have 5 and 1. So this is like one of the very primitive number system. So this is 6, and then you have 7, and this, etc. So this is, you can say that Roman number system is expanding on the above system by bringing in new symbols, and thereby reducing the length of this the symbol for a particular number. So if you look at for example 100 or 50, so 50 here is like just one symbol, very convenient. But if you try to represent it with a tally system, then you will have you will require 10 groups of this, like this. You would require 10, so which is really inconvenient. So this is 15. Okay, so that is really inconvenient, whereas our 15 is here. So to overcome all these difficulties, the decimal number system was invented, and it was a concept introduced in India, and then it was popularized by the Arab traders. Okay, so in decimal number system, if you look at, we have only 10 symbols. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 10 symbols. We no longer require any more symbols. So with just 10 symbols we can go and represent any large number. So that is the advantage. So there is enough number of symbols in order to reduce the length, which is required to handle the day-to-day life numbers, and also you could represent any large number using just only 10 symbols. You don't need to introduce more and more symbol as you go to larger and larger numbers. So how is it possible? The way it is possible is that we introduce a new concept called place values. So which was not there in the earlier number system. So a large number is basically represented by using multiple symbols, or a combination of these 10 symbols. So you are using it in a everyday life. These are concepts which are very familiar to you, but I am just presenting it just to show the distinction. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So after we exhaust all the digits or the symbols, what we will do is basically we will introduce a new position and bring down the symbol to 0. Okay, and then we will continue updating the LSB. LSB means the least significant value, or least significant digit is basically the rightmost digit, and as you go to the leftmost places, it become more it has more place value. Okay, so after 10 what happens? So we keep this 1. So we are assuming that earlier it used to be 0 here. So if you treat it as a 2 digit, and then we are continuing with the 1 here. So with just same symbols, we are now using a new position, new place, and we are continuing to the large numbers. Okay, so this is the way we proceed, and then once we come to 1, 9, what we will do? We will put this to 0 and increase this position. Now the second position, that is the leftmost position, can also go up to explore all the possibilities from 1 to 9, and when that possibilities are entered, after some time, we will, once we reach say 99, then what will happen? The possibilities for the first position and the second position are completely exhausted. Now we need to go for new position. So to go to larger and larger numbers, we keep on introducing new positions. So that's what we do, and then repeat the whole things. Okay, so this is the concept which you are familiar with. Okay, now what is actually a particular number means? For example, 1, 3, 4. What does actually this mean is that this means there is 100, then 3 tens plus 4 ones. So each position has a different value associated with it, and you could write it as like basically 1 into 10 raised to 2 plus 3 into 10 raised to 1 plus 4 into 10 raised to 0. So this is what we are actually meaning. So this is decimal number system. Why? Because the place values have values associated each position has or place has values associated with the power of 10. And how does the 10 arise here? Because there are 10 symbols here. That is why. So once you use each of the symbol, the 10 symbols which are available, you exhaust all the possibilities there. Okay, 0 to 9, these are the symbols also. After that, you have to go to the next position. So that is how the 10 comes into the picture here. So and as you go to the leftmost positions, your place value increases by an order of 1 when you go from one position to the next. So this is so you can, in order to explicitly specify that this is decimal number system that we are talking about, it is also a good practice to put base 10 here. Okay, so that will remove every doubt whether we are talking about the decimal number system or not. Okay, so this is the idea of decimal number system, which is basically contributed by Indians, and therefore this number system is also called Indo-Arabic number system. Okay, Indo-Arabic, basically invented by Indians. This concept of place value was invented by Indians. I think sometime in the Gupta period, I think, and then it was popularized later into the Europe by the Arab traders. And these numerals that we use here, these are Arabic numerals. Okay, so therefore this system is popularly called as Indo-Arabic number system. Okay, so the same concept of place values, that is assigning different values to the positions in a number, can be extended to other number systems. So for example, in this course, what is going to be more popular in digital system design is a number system which is called binary number system. Okay, so in binary number system, so let me go to binary number system. So this is the third number system. So let me use okay, so this is binary number system. Now the concept in binary number system is exactly same as that of the decimal number system. Okay, it has all the advantages or all the conceptual features, but only difference is that we will now use only 2 symbols. Okay, earlier we had 10 symbols, 0 to 9, but now we have only 2 symbols. We restrict the number of symbols to 2. Okay, so which are basically 0 and 1. So this is the only 2 symbols that we will use, and we will use them repeatedly. We will use them in different positions in order to represent a larger. So it is the same concept, but just explored with only 2 symbols. So how do we do that? For example, the smallest possible number is 0, and then we go to 1. Now we have exhausted all the possibilities with just 1 digit. Now no more other single digit number is possible, so you need to go to 2 digit numbers in order to represent the next highest numbers. So what we do, just like earlier, we introduce a new position and bring down this to the first possibility, and then we go to 1 1. Or apparently you can assume that these are basically 0 0 and 0 1 if you want to treat every number with equal number of digits. But this is all that is possible with 2 digits. Now if you want to go to higher numbers, then we need to introduce a new position. So this is 1, and then you can put them to 0. So this is just like after 99 you go to 100. So but here it is basically 1 1 after 1 1. So here we can assume that these are all 0. So we introduced the third position, and we made the first and the second position to 0. And then you go just like before, 1 1 0, and then 1 1 1. Okay, so this is all that is possible. There are 8 combinations now, right? So this is the first 4, and then this is the second 4. So this is all possible, with just 3 digits. So how do we go from here? So if you want to represent a 9 or 8, so this is 7. Okay, so this corresponds to a decimal 0, then 1, then 2, this is our 3, this is our 4, 5, 6, 7. Okay, so that's all what is possible with 3 digits. Now if you want to go to 4 digits, then again you have to introduce a new position, so that is kept 1, and then all other goes to 0. Okay. So if you want to extend it here to 4 digits, you put zeros here. Okay, in order to maintain uniformity, all are treated like a 4-digit representations. Okay, so this is a 4-bit binary representation of numbers from 0 to 8. If you want to go to 9, so you can go 0, 0, 1, and then the next one, 10, is basically 1, 0, 1, 0, 11, 1, 0, 1, 1. These are things that you should by heart, because we will use them repeatedly throughout the course in various occasions. So if you know immediately what is the binary code of decimal number 12, you should be able to write it like this. So the 13, 1, 1, 0, 1, 14, 1, 1, 1, 0, and 15. So this is what you can go up to, where everything is 1. So we have exhausted all the possibility with just 4 digits. Now if you want to go to the next digit, then we need to introduce one more position. So that is for 16, we will have 5 digits, and the last 4 digits are 0. And this goes on. Okay, so you can just continue this concept. So just like I told you earlier, if a random number is given, which number it is in decimal system, if you want to check it, you can just do as we did it before. That is, earlier there were 10 possibilities, so we had a position place value which is in the power of 10, but now there are only 2 symbols, so the place value will have value assigned to it in the power of 2. So for example, let's take 1101. So this is in binary. In order to explicitly mention that, you can put a base 2. Now what does this mean? It means that so you start from the rightmost. So here you have, this is coefficient, or this digit is 1, and it is basically it's like the unit place, and then you have 0, that will be the place corresponding to 2. The place value is 2 there, and then you have 1 into say 4. There are 4 possibilities, and then when you go to here, 1 into 8. Okay, so by introducing the 4 digits, you can have a maximum of 16 possibilities, and that 16 possibilities come like this: 8 plus 4 plus 2 plus 1. Okay, so this can also be represented like 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0. So this is exactly the same way we have written earlier. So 1 into 10 raised to 2 plus 3. So you start from the rightmost digit. We don't have any fraction here. These are all whole numbers. Okay, so we can think about fractions later. So 10 raised to 0, 10 raised to 1, 10 raised to 2. That is how the values associated with the position will change. Okay, so instead of 10 we have 2, because there are only 2 possibilities in that position that is possible. Okay, 0 and 1. If it is 0, the value is 0. If it is 1, the value is 1. And so the maximum value that it can take is when it is 1, and so that is multiplied by 2 raised to 0, which is 1. Okay, so 1 into 1. Okay, or 0 into 1. 0 into 1, that is 0. Now the second position, if you count, there are 4 possibilities that will be introduced with adding the second position. Okay, adding to the in total there will be 4 possibilities, but half of them is due to the second position, and half of them is due to it's basically 2 into 2. So 2 possibilities in the first position and 2 possibilities in the second position, and they are mutually exclusive. So you can have 2 into 2, 4 cases. Okay, so here also you can have two positions. Okay, but on the top of that there are other 2 possibilities in the unit positions. So this is giving rise to a total of 4 positions. And then when you introduce 3 digits, you will have total 8 possibilities. Okay, so that will be basically so if everything is 1, so these 8 possibilities we will always say from 0 to 7. Okay, or 0 0 0 to 1 1 1. So that is how we say. Okay, so and this continues. So this way, if you do this mathematics, so you can see that this is basically 1 into 8, that is 8, plus this is 1 into 4, and this is basically 0, and this is 1. Okay, so this is basically 8 plus 5, which is 13. So 13 to the base 10. So this is basically the conversion that is involved. Okay, so if you are given with a binary number, then you can go and convert that into a decimal number by a simple method of multiplying with its position values. Okay, and the position value changes from right to left in powers of 2, increasing powers of 2, starting from 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So this way it goes. Now how about converting it in the reverse order? So suppose a number is given, something like 90. Now this is to the base 10, and we want to find out what is the base 2 number. Okay, so that is the opposite approach. So what we can do is basically break down 19 with in terms of components which are in powers of 2. Okay, so for example, components in powers of 2 means so 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, and this way it goes. So these are basically powers of 2. So write the 19, you try to write 19 as a sum of these numbers. So that's all what you need to do. And once you know how to write 19 as powers, since 19 is greater than 16, so we will definitely introduce 16. And then 8 we will not introduce. Why? Because if you put 8, it will exceed 19. Can we put 4? If you put 4, that will also exceed 19. So we have to put zeros here. So this cannot be present, this cannot be present, but you can have 2 here and 1 here. So you have written 19 as sum of 16 plus 0 plus 0 plus 2 plus 1. Okay, so any given number you write in terms of the components which are in powers of 2. Okay, so now this has a direct correlation with what we said earlier. If you look at here, no, this one. So these are powers of 2, and whichever powers of 2 is present, you have a 1 associated there. If it is not present, that means the digit is 0 there. So we got the number. So this is basically 1 into 2 raised to 4 plus 0 into 2 raised to 3 plus 0 into 2 raised to 4 plus 1 into 2 raised, oh sorry, I made a mistake. So 0 into 2 raised to 3, it continues to decrease, 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. Okay, and now if you look at these digits, this is our decimal number. Okay, so that you just take them 1 0 0 1 1. So this is the required decimal number representation. So this concept is very convenient to convert. So if you know the concept behind the number system, it is very easy to convert the numbers, the given number from base 2 to base 10, or decimal to binary, or binary to decimal. Okay, let's take one more example. This time let's say 100 in decimal. Okay, so you know 1000 could be also a binary number, because only two symbols are here, 0 and 1, which are also the symbols in binary. So unless we put the base, we really don't know whether it is a binary number or a decimal number. So I am explicitly telling that it is a decimal number, that means base 10, and it is 100. Okay, this is what we refer to as 100. So what is the representation in binary? So what is this number? So this is the question. Okay, so what I said earlier, we need to break down it into components. So you have 2 raised to 5, which is what? You just keep on doubling it, so that way it is easier. 2 raised to 6, so that is 64, and 2 raised to 7, that is going to be 128, and this way. So we don't need a 128 or larger powers of 2. We can just limit here, because our number is 100, and you need to write it as a sum of 64 plus whatever. Okay, so let's do this. 100 can be written as 64 plus what else? Can we add 32? And you check whether if I add 32, whether the number will exceed. So if I do 64 plus 32, what you get is basically 96, which is lesser. So I can definitely add 32 here. And then I cannot add 16 to this. That will not be possible. So I put 0. 16 is not. I cannot add even 8. So again 0. Can I add 4? Yes, I can add 4. And I got the required 100 now, because this plus 4 is exactly 100. And then I don't need 2. I don't need 1 also. Okay, so or in other words, I can say 1 into 2 raised to 64 is basically what? 2 raised to 6 plus 1 into 2 raised to 5, 0 into 2 raised to 4 plus 0 into 2 raised to 3 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. So we got the number. Just take out all this coefficient corresponding to the powers of 2. So that's our binary number. So the number is 1 1 0 0 1 0 0. So you require at least 1 2 3 4 5 6 7 digits to represents this binary number 100. Okay, with 7 digit you can go up to 127, decimal number 127, and 128 will be requiring 8 digits. Now you can also look at this in the form of a puzzle, and the puzzle is like I am imagining a number in my mind which is somewhere between 0 and 0 to 255. Okay, in this range. So this is a puzzle. You can say to your friend that I have a number in my mind, and the number is somewhere from, it's a decimal number. Okay, and I can say that it is somewhere from 0 to 255, one of this number. And then your friend can say that I can find out that number by asking you 8 yes or no questions. Okay, I will ask you 8 yes or no questions, and then if you tell me correctly these 8 yes or no questions, then I will tell you what is the number that you have in mind. So all that is required is the answer of 8 yes or no questions. Now these yes or no questions are basically posed in this particular manner. So we have any number which is from 0 to 255 means the maximum, the biggest number is 255, which requires basically 8 positions in the binary representation. So you denote those positions. So this is 4, and then these are the 4 positions. Okay, so this position I can say it corresponds to 2 raised to 0, and this position corresponds to 2 raised to 1, this one corresponds to 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. Okay, so these are the positions, 8 positions, and each of the position I can put either 0 or 1, right? So in binary representation we put either 0 or 1 in each of this position. So this can be a 0 or 1, this can be a 0 or 1, each position can be a 0 or 1. So my question is framed in such a way that I will be able to find whether it is 0 or 1 here, or 0 or 1 here, etc. So what I will ask first of all is that my first question will be to find out whether this position has a 0 or 1. So how should I ask that question? The first question will be, can anybody tell how to ask the questions, an yes or no question, such that with 8 questions I will be able to figure out the binary number. If I know the binary number, then I can say the decimal number. Anybody? I will give you a chance. How to ask the question to your friend who has imagined a number between 0 and 255. What should be the first question?
So we can ask whether it's a power, it's a result of the subsequent powers of 2 or not.
Okay, so if you, I just want to find out this position, whether it is a 1 or 0. So how should I ask this position? That is the position corresponding to 2 raised to 7. I want to find out whether it is a 0. It has only one of the 2 possibilities. So you can ask a question, yes or no question, from which you can get whether this digit is 0 or 1. corresponding to the place value 2 raised to 7. So how will you ask the question? So question number 1 is the imagined number greater than 127. That's all you need to ask. So he will give an answer yes or no, right? If he gives the answer yes, then I will put 1. If he says no, I will put 0. So I figured out 1 bit out of it. Right? Suppose the imagined number was, say, 136. This was the number in the friend's mind. So when I ask, is this number greater than 127, then he will say yes. So what will I do? I will put 1 here. So can you tell me the next question to figure out the next position? Anyone? So I have excluded half of the possibilities here, because I now don't need to go 0 to 127. I know that definitely those are not the numbers. I have reduced the possibility to just half range. That is, it is from 128. Now I know the number lies between. So once I get the answer to this question, I know that the answer is somewhere between 128 to 255. So by asking the next question, I should exclude half of these possibilities. In the range 128 to 255, I need to exclude half of the possibilities. So how can I do this? So what should be the next question? Are you getting my point? Are you able to understand the question? Are you able to understand?
Okay.
Yes, sir.
Yeah.
So will you please repeat the question, sir?
Repeat.
Yes, sir. From this question 1, sir.
Okay. So I am figuring out what will be the binary representation. First bit means corresponding to 2 raised to 7 place value. I want to know what is going to be this bit, whether it is 0 or 1. So in order to find that out, what I am asking is the imagined number greater than 127? If he says greater than 127, then I know that I have to put a 1, because any number greater than 127 require 8 bits. So the first bit has to be 1. 100 followed by 1 followed by 7 zeros is basically 128. So is that clear? And when I get an answer 1, then I know that the imagined number is somewhere between 128 and 255.
Yes, sir.
Yeah. So what should be my second question in order to get the digit corresponding to the place value 2 raised to 6? This is my number, but I don't know yet. I know that it is in the range 128 to 255. So what should be my next question?
Sir, is the number greater than 64?
We know that is a foolish question, isn't it? Why? Because we know that the number is between 128 and 255.
I mean, lesser.
Repeat. You have to frame a question properly. We have excluded 0 to 127 by the first question itself. So there is no point in searching the number in that range. Now we need to look in this range only. So the question should be such that we will exclude half of the possibilities in this range. In this range.
Sir, is it greater than 191?
Greater than 191. So how did you get 191?
Yeah, 127 plus 64.
Yeah. So that will be 191. So that is how you should ask. Is it greater than 191? And the answer is what if this is the number? What is the answer?
Yes.
Yes. Is it greater than 191? Is 136 greater than
No,
191?
sir.
Oh, so you're taking 136 or 255?
No, 255 is the range. Okay, 0 to 255 is the range. My imagined number is, I will put it in a red box here.
Oh,
This is my
okay, sir.
imagined number. So if I ask the question, is the imagined number greater than 191? The answer is
No, sir.
no. Okay, so if the answer is no, I put 0 there. Now, what is my search range now? It is from 128 to 191. I have reduced my range to this. I know with the two questions I have managed to restrict the range. I have now this much information that it is a number between 128 and 191, which is considerably lower compared to what we started with. We had a range from 0 to 255, but now we have restricted it to 128 to 197. So now tell me, what is the third question?
Is the number greater than 223?
Greater than?
223.
Why do you do that? Because it's not there at all. We have understood that it is between 128 and 191. So why should you want to go out?
Yes, sir, yes.
So how should I ask? 127 plus?
Sir, is the number greater than 160?
Not greater than 160, is greater than 159. Okay, because otherwise you have to ask greater than or equal to. So let's avoid that confusion. So okay, now
Yes,
what
sir.
is the answer? What is the answer? What will be the answer? We assume that the person will answer us sincerely. No,
No, sir.
it's not greater, so we put again 0. Okay, so now we have restricted our range to from 128 to 159. It is one of these 32 possibilities, so we just need to figure out which of that 32. So we require 5 more questions to do that. Okay,
Is it greater than 143?
okay, so is it greater than? So you are basically adding 16 to it, right?
Yes, sir.
Yes, sir.
So if you add 16 to it, then 143, correct. The answer is again no, it's not greater.
No.
So we have managed to restrict it to 143. So there is only 16 numbers in this range. So one of those 16 is the answer. So let's continue it. Question number 5. So what is it? On 27 plus
So is the 135
8, right?
plus 8.
Ah,
Yes, sir.
so 135. So 135. Now what is the answer now?
Yes, sir.
Yes, it is greater because it is 136, which is greater. So what we need to put now is 1 here. So now the range is what? 136 to 143. So what is next question? It's a very narrow range. You see, 136 to 143. There are only 8 numbers. So what should be the next question? One 35 plus 4.
139, sir.
Yeah. The answer is no. It's not greater. It's lesser, right? So it is one of these 4 numbers. Okay, so how many more questions are required? There are we now figured out that either it is 136 or it is 137 or it is 138 or 139. We need to figure out how many questions are required.
Sir, 2 more.
2 more questions. Yes.
Yes, sir.
What is it? Next question. Right?
Yes, sir.
And the answer is a no.
No. No.
Yeah. So that means 0. If the answer is no, means I put 0. And now I know this is either 136 or 137. It's not greater than 137. So now the last question you can ask. What is the last question? You don't need to ask this way. Now there are only 2 possibilities. You can directly ask, is it this number? Is it 136? If you say yes, then put 0. If it is no, okay. So last question I will ask, is it okay 137? Okay, and the answer came is no. So what would I do? I put a 0. Okay, so what I did basically is the concept behind the conversion of a decimal number into a binary number. So the answer is no. I got the answer 136. Okay, so this is just a game. You can, so just 8 questions are only required to find out. 8 yes or no questions are enough to find out the number from 0 to 255. So in other words, we can say that the amount of information present which is required to find out that number is basically 8 bits of information. Okay. All right, I will stop here.